Alright, so today, in order to get a better understanding of electron configuration, we must understand what valence electrons are. Valence electrons are an electron of an atom that is located in the outermost shell, the valence shell of the atom, that can be transferred or shared with another atom. In this picture represented is carbon. Carbon has 6 electrons. 2 of the electrons are in the first shell of the carbon. 1, 2, 3, 4 of the electrons are in the outer shell. These are the valence electrons right here. Here's a representation of a periodic table to help you know how many valence electrons each element has. At the top you can label it 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. For example, carbon we know has 4 valence electrons, and you have the 4 on the top. Phosphorus has 5, bromine has 7, and magnesium has 2. And that's how you guys can go ahead and read that and go ahead and label your periodic tables. So we're going to go ahead and learn about electron configurations, which are the arrangement of electrons in an atom. We're going to learn about the s, p, d, and f orbital groups, and the 3 rules, which include Aufbau principle, Pauli exclusion principle, and Hund's rule. So the way you can think of electron configuration is think of it like a library. Library books have a certain location, and that's how you're able to find them. Like for instance, it'll give you the genre which you can look for. It might give you a letter, maybe even a number, or the author's last name, which gives you a way to be able to locate the book. In a way, you can think of electron configurations in that way. It gives you the location of where to find the element. So right here we have the electron configurations in the periodic table. I'm going to go ahead and give you guys some time to go ahead and fill this out on your periodic tables. So these 2 rows right here are going to be your s orbitals. Go ahead and label them. And over here you're going to have your p orbitals, which you can see goes up to 6. 1, 2, 3, 4, 5, 6. And right here you're going to have your d orbitals. And in between the 5d and 6d orbitals, you're going to have your f orbitals, which today we're mainly going to go through the s orbitals and the p orbitals, so we'll go ahead and go over d and f orbitals in the next lesson. So the first principle we're going to learn is Aufbau's principle, which states that each electron occupies the lowest energy orbital available. So in other words, that means the order is going to go 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and 5f. So as you can see, the numbers vary. Like right here we have a 4, and then we go back to the 3. That's because of the energy levels. So if you guys want to go ahead and copy this, or at least take a picture of it for your use to copy later. Alright, so the next principle is going to be the Pauli exclusion principle. The Pauli exclusion principle states that no more than 2 electrons can occupy a single atomic orbital, only if the electrons have opposite spins. An up arrow is a positive spin and a down arrow is a negative spin. So right here, as you can see, we have a positive and a negative, and then 2 positive spins. That is incorrect. Right here we have a positive spin, a negative spin, and a positive spin and a negative spin. That is correct. You can't have 2 positive spins. You can have a positive and a negative. It's the Pauli exclusion principle. So the next rule is going to be Hund's rule, which states that single electrons with the same spin must occupy each equal energy orbital before additional electrons with the opposite spin can occupy the same orbitals. So right here you see a positive. So you're going to fill in the positives first. Positive here, positive, 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 positive. So it has 1, 2, 3, 4, 5, 6, 7 total electrons. So you put your first 5 positive. 1, 2, 3, 4, 5. Once all those are filled, you can give it a partner now, a negative spin. So your last two are going to be negative, and so this is how your orbital diagram box is going to look. So right here, they put a positive and a negative, and another positive and a negative. This one, they left the positive alone, and this orbital is completely blank. So remember, you have to fill out all the orbitals with a positive before you can go ahead and pair them with a negative. That's going to be Hund's rule. So let's go ahead and do an example. So we did carbon earlier, so we know it has 6 electrons. So its electron configuration is going to be 1s2, 2s2, 2p2. So from here, since we know it has 6 electrons, we're going to go ahead and put those. So we're going to put one positive here, a positive here, 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 and here. So that fills up 5. So we have one more, which we can go ahead and give it a negative spin. So this is how your diagram box is supposed to look for carbon. So let's go ahead and do a little bit of practice. So I'm going to give you about 30 seconds to give me the electronic configuration for chlorine. I went ahead and gave you the number of electrons chlorine's supposed to have. Alright, so the correct electron configuration should be 1s2, 2s2, 2p6, 3s2, 3p5. So an easier way or a faster way to go ahead and write this is by getting the noble gas that comes before this element and then going from there. So for chlorine, it's going to be neon, and then you're just going to go ahead and put the 3s2, 3p5. It may not look so useful now, but when you get elements that are lower down on the periodic table, it saves a lot of time than having to write out the whole configuration. Alright, so now I need you to go ahead and give me the electron configuration diagram box for chlorine. I'm going to give you about 30 seconds for that as well. Alright, so we have 17 electrons that we get to fill in, so let's go ahead and fill in the positive ones first. Here, 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 and here. So now we can put the remaining electrons with negative spins. And the last one doesn't get one, so this is how your electron diagram box is going to look for chlorine. Alright, so now I gave you the diagram box. So what I need you to tell me is which element is represented. Give you about 30 seconds for this one as well. Alright, so if you said that this element is calcium, then you are 100% correct. So right here it tells you that there's 20 electrons. So if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then you'll know that that's going to be calcium. Alright, last one. What element is represented? I went ahead and gave you guys the electron configuration, and I gave you the shorter version as well. Give you about 10 more seconds to go ahead and come up with an answer. Alright, so we're going to go ahead and get copper for that one. So congratulations, now you're ready to go deeper into electron configuration.